Good day. My name is Michael Indab. I'm here to present our thesis on design, fabrication, and testing of a residential window frame integrated with thermoelectric generators. Since our country uses 85% of non-renewable energy, our team wants to promote and use renewable energy and utilizing the civic effect. We have two statements of the problems, which are first, how our study is different from other researches. Since there are multiple articles and studies about civic effect, we want to stand out. We want to improve it, give another information or add another use. Second, how will be the proposed window frame affect the efficiency and power output? Since it is being implied to the window frame, we want to test if it will be economical or the power output produced would be efficient to use as a renewable energy. Our main objective is to utilize the thermal difference between an ambient temperature and a room temperature, which will be able to generate electricity and can be used as an alternate source of energy. Also, we want to design, fabricate, and integrate the TEG to a residential window frame that will work and produce electrical energy. Added that we will be able to compute, gather the parameters, which will be able to find the number of hours to take charge a 7,800 milliamperes of a power bank device. Also evaluating the TEG by analyzing its computed efficiency and power based on the thermal difference produced, where we need to test, check if it's economically usable as a alternative source. Our significance of the study is first, if this prototype will be economical for a single detached household. Second, the data gathered will be able to improve and support incoming studies on thermoelectric generators. Also, if it will be able to be used in future applications. And maybe we can add the efficiency in the future. The study may also be used on harvesting electrical energy by other means for small to medium scale electrical devices. For scope and limitation, since our study is focused on the TG, we're focusing on the design itself, the data gathered, and mostly in data gathering, our data are limited from the room temperature and the ambient temperature, also the thermal difference. Mostly that is where we gathered our data. Next is our methodology. This is our flowchart, and this is the process in how we did our thesis prototype. I will be discussing it along the way. First is we designed our prototype using Fusion 360. As you can see, this is the front, side, and the top view of our prototype design. Next is this is the actual window frame design. We cut the holes using a drill press machine, and then we integrate or install the thermoelectric generators with a cooling fin inside the holes. Then in the sides, we place insulator to maintain the temperature of the room and the ambient temperature. We glue them together, the TEG with heatsink using a thermal paste. The heatsink is used to lower the room temperature since more fins it will reduce the heat. Next is we added a USB connection for the power bank to be charged. And this is how we put it in the setup. We place the power bank charger at the bottom right of the prototype. And this is the actual setup. We place it into a room where it will would be able to receive direct sunlight and be able to be access the room temperature as well. This is how we measure our thermal difference and voltage. To measure the thermal difference, we measure the uh, room temperature using a thermal scanner and the ambient temperature is using by the pag-asa temperature reading. And then the electric or voltage is we're using multimeter to gather its power output or voltage output, I mean. Next is our results and discussion. We measured the experiment for 3 days. This is the data for theoretical and voltage output. As you can see, this was measured for day 1, 2, and 3. It has peak time of 1:45 p.m. to 2 p.m. And this is the heat input temperature gradient data. Also, it is higher in 2 p.m. since in our time, in our local time, 2 p.m. is the peak of our sun. Then efficiency and power. For our conclusion, we conclude that utilizing the temperature difference between the ambient and room temperature frame is mounted, it produces a small amount of voltage. Because the small amount of voltage is dependent on the temperature difference. So since it's summer, both sides are actually hot and can cause a lower small out slower or small amount of voltage. Then next is using machine tools and equipment will be able to ease off of your work in designing and fabricating the window frame. And also concluded that our using of aluminum frame induced and helped boosting the ambient temperature. Also, the group was able to gather the needed data during the experiment and to compute the necessary data parameters using empirical equations and able to determine the number of hours and charging a 7,800 milliamperes power bank. And also that we have a low efficiency and power output were produced based on the data gathered as you see earlier. We recommend that is to find a device to emit a high temperature and low temperature to benefit the use of the thermoelectric generator since TEGs are temperature dependent. We also recommend to add a heat exchanger in the system to produce a greater temperature differences. Also, having the right tools and equipment will be an advantage in designing and fabricating your prototype. Data parameters may be evaluated using technical references and similar studies found online. Also, implementation of heat exchangers by utilizing of waste heat recovered from the condenser and AC system. Thank you for watching. Thank you for listening. Have a good day.